Welcome back, guys. Today's video, we're going to talk about the Silurian period. That's a fun word to say, isn't it? Silurian. So, we're talking about the time that life rebuilds after an extinction period. Okay? So, it's pretty similar to the Devonian, and we're actually going to kind of compare and contrast. But the Silurian was right before the Devonian period. So, you'll see a lot of things that kind of move into the Devonian period. Now, for those of you who don't know me, I'm Miss Bree, educator, farmer, illustrator, singer, and grammar nerd. Welcome to the farm school. So let's take a journey far back in time, so far back that there were no dinosaurs, no birds, not even any flowers yet. We're traveling more than 400 million years into the past, to a time scientists call the Silurian period. The Silurian was part of a very long chapter of Earth's history called the Paleozoic Era, which means ancient life. If you looked around during the Silurian, you would see vast oceans full of strange creatures. Land, however, would look mostly rocky and bare. Only tiny plants had just begun to grow there. The Silurian was a time when life was recovering and experimenting with new ideas, especially the idea of living on land. Now, each slide we're going to have a vocabulary word or a fun fact or both. So for this slide, our vocabulary word or phrase is geologic period, which is a long section of time in Earth's history. And did you know that if Earth's history were a 24-hour day, the Silurian would happen around 9:30 p.m.? It's true. So let's talk about how life recovers after an extinction, right? So just before the Silurian began, something dramatic happened on Earth. A huge environmental crisis caused many ocean animals to disappear. Scientists estimate that about 60% of marine life vanished during what we call an extinction event. 60% would be 6 out of 10 animals disappeared. But Earth's story didn't end there. The 40% of creatures that did survive began to adapt and evolve. Slowly, new species appeared and ecosystems started rebuilding. Think of it like a forest after a wildfire, right? At first, everything looks empty, but over time, new plants grow, animals return, and life begins again. The Silurian was exactly that, a time when life began rebuilding the planet. So, extinction. What is extinction? Extinction is when a species completely disappears from Earth. And scientists call the biggest extinction events, there's 5 of them, and they call them the Big Five. Now let's look at land during the Silurian. Before this time, most life lived in the oceans. And even during this time, most life still lived in the oceans. Land was mostly bare rock with very little living on it. But during the Silurian, tiny plants called Cooksonia began growing on land. Cooksonia might look simple to us today. It had small stems and no leaves, but it had something very important inside its body called vascular tissue. These tiny tubes carried water and nutrients through the plant, helping it survive outside water. This small change helped plants begin spreading across land for the first time. Even though Cooksonia was only a few centimeters tall, that's not very tall, it helped start one of the biggest transformations in Earth's history, the greening of the continents. A vascular plant, let's recap, right? We learned about a vascular plant. That's a plant with tubes that move water and nutrients. And did you know Cooksonia plants were only about a few centimeters tall? Remember, we learned about that? Did you know that's smaller than your hand? That's like just a couple inches. It's little teeny tiny. Yeah. Now, keep in mind, plants did not conquer land alone. They had a helpful partner, fungi. Fungi lived in the soil and formed partnerships with Plant roots, sorry. This type of partnership is called symbiosis, which means both living things help each other, right? Symbiosis, that's our vocab word. When two living things help each other survive. The fungi helped plants gather nutrients from the soil, and the plants gave the fungi energy from sunlight. This teamwork allowed early ecosystems to grow stronger and healthier. Even today, many plants still rely on fungi and their roots to help them survive. Did you know that? It's pretty cool. So, when plants first began spreading across land, they were really part of a team effort between plants and fungi. Okay, now let's talk about the first land animals. Not the first land, like animals that you and I know of, but we're talking about like insects, right? So, once plants began growing on land, animals soon followed. Some of the first creatures brave enough to explore land were arthropods, animals with jointed legs and hard outer shells. That's called an exoskeleton. So, an arthropod is an animal with jointed legs and a hard outer skeleton. These early land explorers included millipedes, spider relatives, and insect like creatures. One of the oldest fossils we know is a millipede called Pneumodesmus, which lived more than 428 million years ago. That's crazy far back. Scientists know that it could breathe air because it had tiny breathing holes called spiracles along its body. These early land animals probably crawled through moist soil and plant patches, helping form the first land food webs. While plants and small animals were beginning to explore land, the oceans were also undergoing a revolution. Fish with jaws began to appear. Before this time, many fish had no jaws at all. They could only filter food from the water. But a jawed fish could grab prey, chew food, and become active hunters. Some of the earliest jawed fish were called sorry, this word always throws me, acanthodians, which had spiny fins and bony scales. This change was incredibly important because it eventually led to the evolution of all vertebrates. Now, a vertebrate, remember, it's our word, is an animal with a backbone or a spine. This included amphibians, reptiles, birds, and even mammals like us. In other words, the story of animals with backbones really began to accelerate or speed up during the Silurian. Did you know that jaws evolved from bones that had originally supported fish gills? They did. Now let's talk about one of the most exciting creatures in the Silurian seas. This was called the Eurypterid, also called the sea scorpion. Despite the name, they were not actually scorpions. Instead, they were related to modern spiders and horseshoe crabs. Some Eurypterids grew to incredible sizes, longer than a person is tall. Let me tell you, from my standpoint, I would really, really prefer not to see one of those in person. That would be terrifying to me, but it was normal back then. These giant predators used their large claws to catch fish and other animals in shallow waters. Predator means an animal that hunts other animals for food. Imagine walking along a Silurian shoreline and seeing a creature as long as a canoe swimming beneath the waves. For many millions of years, Eurypterids were some of the top predators of the oceans. Isn't that crazy? The warm Silurian oceans were also perfect for coral reefs. Reefs are large underwater structures, like cities, built by living organisms like corals and sponge like animals. These reefs became busy underwater cities filled with marine life. They're kind of like a ocean version of New York City. Animals such as brachiopods, corals, and many small sea creatures lived there. Now, reef, remember, reef is a large underwater structure built by living organisms. And did you know that some ancient reefs stretched for hundreds of kilometers? That's way longer than a lot of modern cities. Reefs provided shelter, food, and protection, allowing many species to thrive. Now let's talk about the continents, right? Because today we have 7 of them. But back then we didn't have the same continents, right? And we haven't throughout history. So, Earth's continents were not always in the places we see today. During the Silurian period, several land masses slowly drifted toward one another. These continents, called Avalonia, Baltica, and Laurentia, moved together near the equator. Eventually, they began forming a larger landmass known as Euramerica. This was called a supercontinent, and this slow movement of continents is called continental drift, which is the slow movement of Earth's continents. Okay, that's our vocabulary word here. Now, even today, Earth's continents are still moving, but did you know that they move about as fast as your fingernails grow? Yeah, it's pretty cool. So, what about mountains? Where did they come from? Well, when continents move and collide, the land crumples and folds, like when you smash a piece of paper between your hands. This creates mountains. During the Silurian, a major mountain building event called the Caledonian orogeny took place. Caledonian orogeny took place. This event formed mountain ranges stretching across what are now parts of North America and Europe. Now, orogeny means the process of mountain building, right? Some of the ancient rocks created during this time helped to shape the early ancestors of the Appalachian Mountains. Now, these geological events changed landscapes and influenced where rivers, oceans, and ecosystems developed. The Silurian Earth was generally very warm. It had something called a greenhouse climate, which is when gases trap heat and warm the planet. So, because the carbon dioxide levels were much higher back then than they are today, this trapped the heat in, right? And that created essentially a big greenhouse. Hence, greenhouse climate. Warm, shallow seas covered many parts of the continents, providing ideal environments for reefs and marine ecosystems. These warm conditions helped marine life recover and expand after the earlier extinction. And this warm ocean climate was warm enough to support the huge reef systems that we talked about earlier. Now, even though the climate was really warm, the Earth's oceans were constantly changing. Sea levels rose and fell many, many times during the Silurian. At some points, the ocean was about 140 meters higher than at other times. That's about as tall as a 40-story building. Can you imagine the ocean being one level and then the next time you look, it's 40 stories taller? That's crazy. Isn't that nuts? Now keep in mind the sea level is the average height of the ocean's surface. So when sea levels rose, shallow seas spread across the continents, and when they fell, more land was exposed. These changes helped shape ecosystems and sometimes caused species to struggle or adapt. Now let's talk about climate events, right? And today we're going to be talking about isotopes for this. And an isotope is a version of an element used by science to study ancient climates. Okay, scientists read clues in rocks like detectives reading fingerprints. It's pretty cool. Whoop, I hang on, moving ahead. Scientists studying Silurian rocks have discovered clues about the sudden environmental changes. These changes appear as chemical signals, and these are called isotopic excursions preserved in ancient rocks. Some of these events have names, like the Ordovician event, the Molde event, and the Lau event. During these times, ocean chemistry changed quickly, and some species disappeared. These events remind us that Earth's climate has always been dynamic and constantly changing. Now let's talk about early land ecosystems. And what is an ecosystem? A community of living things interacting with their environment. Good job. Now, as a fun fact, the first forests would not appear until later in the Devonian period. But by the later part of the Silurian period, land was beginning to look a little greener. Small moss like plants had started to spread across damp areas, and tiny arthropods crawled among them, feeding on plants or other animals. These simple communities formed the first land ecosystems. Though they were small and simple compared to modern forests, they were incredibly important. They laid the groundwork for the giant forests and complex ecosystems that would appear in the next period, the Devonian. The Silurian period was a time of rebuilding and innovation. During this period, hang on, oh my gosh, I keep doing that. Plants began spreading across land. Animals started exploring terrestrial habitats. Jawed fish transformed ocean ecosystems. Coral reefs flourished in warm seas. These changes set the stage for some of the most dramatic evolutionary developments in Earth's history. Without the Silurian, the forests, animals, and ecosystems we know today might never have existed. In many ways, the Silurian was when life began preparing the planet for the future. And our word here is evolution, which is the gradual change of living things over time, right? So many animals, in fact, all animals today, trace their ancestors back to Silurian creatures. That's right. It's pretty cool. Now let's review our vocabulary that we went over, right? So we've got earth science words that we learned, right? So we've got the geologic period, continental drift, sea level, orogeny, and isotope. We've got life and evolution words we learned, like evolution, extinction, predator, and vertebrate. Plant and ecology words like vascular plant, symbiosis, ecosystem, and reef. And lastly, we even learned an animal group word called arthropod. That's right. Good job. Thanks for coming today, guys. I hope you enjoyed this one. If you haven't seen the Devonian one, you're more than welcome to go check it out. If you have, there's a bunch of other videos, and we add a new one every single day. So follow along for more. Thanks for coming.